Hello, my mathematics lovers. Let me use this short video to introduce us to the concept of mean and standard deviation. In carrying out scientific research, if you have gathered your data from a population, you will need to analyze the data. And most of the common analysis you carry out on the data, you want to look for the average, which is called the mean of the data set. You want to look for the standard deviation and stuff like that. So those are very common analysis that you need to carry out, and that's why we are doing this video. So there are two ways of analyzing data. Is either you are analyzing the entire population or you are analyzing a sample of the population. Let's assume you have a population of maybe 500,000 or 1 million people, and you've gathered information about a certain attribute of the population and you want to analyze this data. It is not likely that in gathering the data you'll be able to go around 1 million people collecting sample data. So in that case, you just take a sample, maybe like 20, 50, 100, what you can conveniently analyze. So that's the kind of thing that you are seeing here. In this population, you have a total number of the population to be 5. But we have seen that, okay, this population is too big. We want to just take just 3 representative sample out of that population to analyze. So that sample will still give you results that are close to what that population will give to you if you were to analyze the entire population. So the first thing you want to do is to know the sample size. N here represents the sample size. And then, assuming you were analyzing for the entire population, you will need to get the average, which is the mean of that population. If you're analyzing for the entire population, that mean is called mu. While if you're analyzing for the just a sample, it is called x bar. This is the sample mean, while this is population mean. So how do we analyze the population mean, mu? It's very simple. It's just equals to the sum of the entire population all over the sample size, all over n. In this case, that means we are going to sum 2 plus 4 plus 5 plus 6 plus 8 all over 5. So this will give us so if you sum this, it will give you 25 all over 5. That gives you 5. So mu, which is a population average, is 5. In the case of this other side, now let's also calculate the sample mean. For the sample mean, is just the same method. You are just taking an average of those numbers that you pulled out as sample. And if you look at this, sample mean is the same thing. Sum all over the n. 2 plus 5 plus 8, that gives you 15 all over 3, which equals 5. In this case, both the population mean and the sample mean gave us the same figure. It is not every time that the population mean and the sample mean will give you exactly the same result. But what you can be sure of is that they will be close, because this sample was taken from this entire population. Now the next thing is the standard deviation. For the population, the standard deviation is represented by sigma, while for the sample, the standard deviation is represented by S. So what is the standard deviation in the first case? I've drawn this number line to represent these numbers. So this is 2, let's assume this is 4, 5, 6, and this is 8. While for this is 2, 5, and 8. Having gotten the mean to be 5. So this is the mean of this population. Standard deviation is trying to tell us how far away the rest of the numbers are from the mean. That is the spread away from the mean. You want to calculate that spread away from the mean. So these are the equations for calculating the population mean and the standard mean. These two equations, they are very much alike. The only thing that is different is that here the population mean is represented by mu, while in the case of the sample is represented by x bar. That's all. And then in the case of the population mean, you are going to divide this expression by n, which is the number of the samples. But in this case, you are dividing by n by 1 for the population sample. And how do you go about calculating the population standard deviation? Look at it. Look at it. It's very easy. You are going to subtract all of the numbers from the mean, and then you square each of them like this. So the first number for the population mean is 2. So 2 minus the mean, which is 5. I'll square it, plus next number is 4 minus the mean. The next number is 6 minus the mean. The next number is 8 minus the mean. And then I'm squaring everything. Then I would divide by n. The sample size for the population is n, which is 5. And everything under the square root sign. I hope this is clear. How many are there? 1, 2, 3, 4. There's still one we're missing. 1, 2, 3, 4, 5. So I've got 2, I've got 4, I've got 6. So there is also 5 there that we omitted. There's a 5 among the figures. So 5 minus 5 times squared. So all of them 5. All right. So 2 minus 5, that's 3. So that's minus 3 all squared. Minus 3 all squared. Plus 4 minus 5, that is minus 1 all squared. Plus 6 minus 5, that is 1 squared. Plus 8 minus 5, that is 3 squared. Plus 5 minus 5, that's 0. All over 5, everything under the square root sign. Right. Okay. When you're squaring any number, the minus sign disappears. So this becomes 3 squared, which is 9. Plus minus 1 squared, that's 1. Plus 1 again. Plus 9, plus 0. All over 5, and everything squared. All right, so 9 plus 1, 10, plus another 10, so that's 20. The square root of 20 over 5. 20 over 5 is 4. The square root of 4, which equals 2. So the population mean, sigma, equals 2. Got one of our results. Now we want to calculate the mean of the sample, and this is the formula that we're going to use. So the mean is simply S equals the square root of, for each of the numbers in the sample, 2 minus the sample mean, which is 5, square it, plus 5 minus the sample mean, you square it, and plus 8 minus the sample mean, which is 5, and then you square it to all over This time around is n minus 1. The sample is 3 numbers, 3, and then n minus 1 is 2. So that is 3 minus 1. All right. So that will give us square root again. 2 minus 5 is minus 3 all squared plus 0 squared plus 3 again all squared all over 3 minus 1 is 2. So that gives us, what is 3 squared is 9, minus 3 squared rather is 9, plus 0 plus another 9 all over 2. So 9 plus 9 is 18 all over 2. That equals root 9. That's root 9. And square root of 9 equals 3. So we'll go back to plug our answers in here. So we'll go back to plug in our numbers. Remember when we worked it the first time, the standard deviation for the population was 2. So population standard deviation is 2, while the sample standard deviation is 3. So guys, what is this information telling us? This information is telling us that for the entire population, the data is deviated from the mean by just 2. While for the sample, the data deviated from the mean by a standard deviation of 3. Meaning that for the sample, you have more spread away from the mean than for the population, where in combining everything, you have the standard deviation of 2 compared to this. So that's how you interpret the data in the statistical analysis. I'm sure this was simple enough. We are still going to walk 1 or 2 more examples in mean and standard deviation. Thank you. Bye for now.